Exponential graphs is a study of the graphs of the form y equals some number, some base number, which we're going to write as a to the power of x. And this will be different to any of the graphs you've seen so far, because in this particular graph, the x is the exponent. So obviously, as x increases, we're raising the value of a here to a higher and higher power. And I'm going to give an illustration of this with two graphs. We're going to start off with y is 2 to the power of x, and the second graph we're going to look at is y is equal to a half to the power of x. And we're going to start looking at this with just by drawing a table of values, x and y values. Let's just have a look from -3 up to the value of 3 for both of these. So that's a 2 there, and x and y to look at -3. So let's have a look at what happens to this graph here as when x is -3, what we get is we get 2 to the power of -3, which is 1 over 2 cubed, which is an eighth, or 0.125. Here we're going to get 2 to the -2, which is 1 over a quarter. Here we're going to get a half. 2 to the power of 0 here is going to be 1, because anything or any non-zero value to the power of 0 is 1. Here we're going to have 2 to the 1, which is of course 2, 2 squared, which is 4, and 2 cubed, which is 8. So these are the values here that we need to graph. And let's have a look at this particular graph here. I'm going to get a half to the power of -3, which is equal to 8, and you should be able to prove that to yourself, that that's equal to 8. This value here will be a half to the -2, which will be 4, and this will be 2, 1, a half, a quarter, and an eighth. And what we're going to do is we're going to plot these two particular graphs on a set of axes, which is what I've drawn here for us. So what I've just done there is I've moved this a little bit higher up the scale so that we can see our values here, and I'm going to plot the points from this particular graph here to start off with. So when x is -3, which is over here, hang on, let me just put some y values in as well. So when x is -3, the y value is an eighth, which is way down here. -2 gives us a quarter, which will be here. -1 will give us a half here. When x is 0, we get 1, and then we get 2, and then we get 4, and then we get 8. And you'll see that as x here gets bigger and bigger and bigger, obviously this is going to get larger and larger and larger, and it gets very large very quickly. And the graph will look something like this. Now over here on the left hand side, as x gets smaller and smaller and smaller, this graph obviously gets very, very close to the x-axis, but never actually reaches the x-axis, and so the x-axis is an asymptote. And as the values of x get large, this graph just gets larger and larger very quickly, and y values will become infinitely large. With the graph of y equals a half to the power of x, you'll notice that this works the other way. Because we're raising a fraction to a power, as x gets larger and larger and larger, the fraction gets smaller and smaller and smaller. And this is almost a reflection of the original graph in about y equals x. They'll both go through 0 and 1, because it doesn't matter whether you have 2 to the power of 1 or a half to the power, 2 to the power of 0 or a half to the power of 0, they'll both equals 1, and then we'll have 2, we'll have 4, we'll have 8, and this is a graph which is going to come down the other way. Obviously it goes through those lines. Very hard to draw on this tablet. So here we have y equals 2 to the power of x, and here we have y equals a half to the power of x. And here's two that I've previously prepared just so as we can see it a little bit easily. The blue line here is y equals 2 to the power of x, and the green line here is y equals a half to the power of x. And if we have a look at the graphs here, you'll see the blue line getting larger and larger and larger. Both of them go through the point of x equal to 0, y equals 1. And you'll see that they are very much a mirror image of themselves across the y-axis here. So what I'd like you to take away from this is that these are the graphs of the form y equals a to the power of x, and a is our base, and the main point from this is if a is greater than 1, then we're going to have a graph which gets very, very big very, very quickly, and it's going to look that way there. And whereas if a is less than 1, then we're going to get a graph which looks gets very, very small very quickly, and we're going to have a graph which moves the other way here. And if I just switch back to here, you'll see that this line here is when a is smaller than 1, but greater than 0. We'll talk about that in a second. And this blue line here is the graph where a is greater than 1. And what you might ask, what happens if a is less than 0? Well, because we're dealing with logs and indices, at year 11 level, we don't look at anything where a is less than or equal to 0. So a will always be positive. And to reiterate, if a is a number greater than 1, we get a graph which goes very positive or very large very quickly. If a is less than 1, we get a graph which goes the opposite way and gets very, very small very quickly. A couple of things to note about every exponential graph. So here we have y equals 2 to the power of x. When x is 0, y will always be 1, because anything to the power of 0 will be 1. And when x is 1, y will be 2, because 2 to the power of 1 is 2. What happens if we have y equals 3 to the x, or y equals 4 to the x? Let's have a look at y equals 3 to the x, which is now this red line here. Again, x is 0, y is 1, because it doesn't matter whether it's 2 to the power of 0 or 3 to the power of 0, or even, if we can bring up this other line here again, a half to the power of 0, anything to the power of 0 is 1. And when x is 1, the red line now is going to go through 3. So this is y equals 3 to the 1. And if it was 4 to the 1, obviously 4 to the power of 1 is 4. It would go through this point here. 5 to the 1 would go through this point here. Let's have a look at any particular value of x. So let's turn off these specific graphs. Let's have a look at y equals a to the x. And obviously if a is 1, we don't get an exponential graph, we just get a horizontal line, because 1 to any power of all is just 1. But when a is non-1, you'll see that when a is greater than 0, as we said, we had a graph which gets very large very quickly. Let's have a look at y equals, when a is 3, obviously it goes through 0, 1, and it goes through 1, 3. If a was 4, it would go through 1, 4, or 1, 4.1 there. And let's have a look at what happens when a gets less than 1. It'll go back the other way. So the value of a, or the value of the base, will affect the shape of the graph. But the two things to really take note of is that it will go through the point 0, 1, and 1, whatever the base happens to be. If it was 3, it would go through the point 3. Whoops, that happened there. Let's have a look at 4, and obviously x is 1, y is 4. If the base was 5, it'll go through 1, 5. If the base is 6, it'll go through 1, 6. If the base was 2.5, it would go through x equals 1, y equals 2.5, which would go through there.